Example 2. How much should new parents invest at 8% to have $80,000 towards their child's college education in 17 years if interest is compounded continuously? Okay, so if you saw this on a quiz or an exam, okay, the key phrase here is compounded continuously. Okay, as soon as you see that, you know you're going to have to use the PERT formula. Okay, so what's going on here? The new parents want to save for their child's college education. Their goal is to have $80,000 saved for in 17 years. They want to have that much money. So you're trying to figure out how much should they invest. Okay, so it's implied here if you read it that this is one lump sum that they will be investing at 8% for 17 years, and they want that money to have grown through interest to $80,000 after the 17 years. Okay, so here we're saving money, it's one lump sum, and the interest is compounded continuously. So this is going to be the PERT formula. Okay, all right, let's figure out what we're looking for, what we know. Okay, let's do our obvious stuff first. The interest rate is 8%. Convert that to a decimal. Time is 17 years. That's how long they're going to save the money for. Okay. So remember, there will be no M value. So now we're down to A or P. Okay. P is the amount of the original deposit. Okay. That's what we're trying to figure out. What is this one lump sum that these new parents need to deposit? Okay. So that money will grow to a future value of $80,000 in 17 years. Okay. So they want to have an account balance of $80,000 17 years down the road. Okay. All right. So let's go ahead and plug all of this in. So we're going to have 80,000 is equal to P times E raised to the R times T. Okay, so that's all you have to do to plug it in. Okay, we're solving for P. What has to be this original deposit? Okay, all right. You should expect obviously something, a number less than 80,000. Okay, so let's go figure out what it is. On the right side, P is multiplied by this quantity E raised to the 0.08 times 17. Okay, so let's go figure out what that is. Okay, so if you go to your calculator, we're just going to go ahead and we're going to do second natural log to raise e to a power. Okay, e is going to be raised to the 0.08, that's r times t, which is 17. Okay, and there you go. Okay, so that's this number that P is being multiplied by. You've got to carry all of these digits. Okay, cannot round here. Okay, only round the final answer. All right, so let's go write this down. Okay, so we're going to have 80,000 is equal to P times, we put this in the calculator and we got 3.89619332. All right, so that's what P is being multiplied by, okay? So then if you want P, since P is being multiplied by this decimal, we need to divide it off, okay? So whatever you do to one side, you have to do to the other. Okay, so let's divide on this side. All right, and then on the right side, this will cancel with this, and it will leave you with P. Okay, so let's go to our calculator and do 80,000 divided by this decimal. Okay, so let's see, we're going to do 80,000 divided by, okay, you can either type this in and carry all the digits, or you can do second, the minus sign right here. So second answer, okay, and it'll, divide by that previous number, okay? So here we go, okay? This will be our answer if we round it to the nearest, and this is money, okay? This is how much the new parents need to be investing, okay? So let's jot this down. All right. So it looks like just over $20,000 will do it. Okay. So let's round. Okay, so you've got 86 cents. You've got a 2 coming after it. So the answer to the question is the new parents need to invest one lump sum of $20,532.86. Okay, and by investing that one lump sum and forgetting about it and letting it earn continuous compound interest at 8% for 17 years, they will achieve their saving goal of $80,000 for their child's college education. All right. Let's look at example 3. Okay, so move this. Whoops. Okay, here we go. Example 3. How long will it take money to quadruple if it is invested at 5% compounded continuously? Okay, again, you read this problem. Okay, first thing you should pick up on is compounded continuously. That should jump out at you, and you know automatically to use PERT. Okay, all right, so here we go. How long will it take? Okay, so when you read this, okay, we are solving for time. How long is it going to take our money to quadruple? Okay, we know the interest rate. The interest rate is 5%, so change that over to a decimal. Okay, and we've seen a problem like this before where what's left for the formula is A and P, okay, and we have to fill those in because time is what we're solving for, so we have to have a value for P and we have to have a value for A. So we saw something like this when we studied, when we did 3.2 and 3.3, where they don't give you the amount of the initial deposit, okay? I think back in that example, we were doing money tripling, okay? But now our money's quadrupling. It's gonna work the same way. Remember what I told you. If they don't give you the value, just make it up and you can use whatever you want, okay? So I usually keep it simple. I just say, okay, I'm gonna invest this one lump sum of $100, and then I wanna know later on, I want my account balance to have the money quadrupled. So you would multiply by 4. So that means you would have a future value of $400, okay? So that's all you have to do, okay, when you encounter a situation like that, okay? All right, so we're going to plug all of this into the PERT formula. So you're going to get 400 is equal to 100 times E raised to the 0.05 times T, okay? All right, so we've got to solve this for T, okay? Again, one of those tricky situations because T is in the exponent, okay? So that's one of those exponential equations, okay? We solved both regular compound interest and the future value of an annuity. We've worked with both of those formulas as far as solving for time, okay? The steps here are going to be similar, okay? You essentially, first, let's go back through our steps. Okay, the first thing you're going to have to do is isolate the quantity that contains the power. Okay, so when you look at the right side, what is being raised to the 0.05 times T power? Just the E. Okay, the 100 is just out front. Okay, there's no parentheses here. So only what's immediately next to the power is what's being raised to the power. So we need to isolate this guy, okay? So your first step is going to be, and I'm just going to rewrite it so we don't get confused here, okay? Our first step is going to be getting rid of the 100, okay? So to do that, since E to the 0.05 times T is multiplied by 100, we're going to undo that by dividing by 100, okay? Whatever we do to one side, we have to do to the other. So on the right side, this 100 will cancel with this one, okay? So on the left, 400 divided by 100 is 4. That is going to equal E to the 0.05 times T, okay? So now that quantity that contains the exponent has been isolated, okay? All right, what did we do next? Once we isolated the exponential piece, okay, then you bring in the natural log, okay? You're going to take the natural log of both sides. So we're going to get the natural log of 4 is equal to the natural log of E to the 0.05 times t. Okay. All right. So why do we do this? Okay. Because remember that property of logarithms. Okay. On the right, we have the logarithm of something to a power. Logarithm of something to a power. So you're allowed to take the power and bring it down in front in the next step. Okay. So we're going to get the natural log of 4 is equal to 0.05 times t times the natural log of e. Okay. All right. So now what we can do here is simplify here. This is great. We're on the right track because t is now out of the exponent. Okay. So it's a lot easier to solve for. Okay. All right. So one thing I want to show you really quick. Natural log of e. Okay. I think I mentioned to you back when we first started talking about logarithms. Natural log is a base e logarithm. So ln and e actually have a very special relationship, okay? If you do the natural log of e, okay, that's just 1, okay? So really, and I'll write that down for you, okay? Put it right here, okay? Natural log of e is just 1, okay? And it's okay if you don't remember that. When you plug it all into the calculator, it would do it for you, okay? But essentially, this would turn into the natural log of 4 is equal to 0.05 t times 1, okay? So you get that the natural log of 4 is equal to 0.05 times t, okay? All right, so let's keep going, okay? So remember when we solved for time previously, we always solve for m times t instead of just t, okay? It's a little bit different here because we don't have an m value. So because this formula does not have an m value, we're just going to go ahead and solve for t, okay? Our answer will be a decimal for time, but that's okay. That's just what we're going to end up with, okay? So if we want to get t by itself, t is multiplied by 0.05. So we're going to have to divide both sides by 0.05. Oops, an extra 0 in there, okay? So on the right side, this cancels with this, and then you're just going to get t equals, okay, let me erase this. So kind of looked weird when I wrote it down. Okay, so we're going to go to our calculator, and we're going to get the natural log of 4 divided by 0.05, okay? So here we go. We're going to get the natural log of 4, okay, divided by 0.05, okay? And that's going to be your time value, okay? Like I said, because this doesn't have an m value, we're just going to leave our time as a decimal here, okay? It is what it is. All right, so here's your output from the calculator, okay? I'll go ahead and round time, okay? We'll say time is approximately 27 point, I don't know, 73 years, okay? All right, and that's all you have to do, okay? So that's continuous compound interest in a nutshell, okay? I just wanted to show you a couple of problems. We will now move on to section 3.4. You are going to learn the last two problems on, or the last two formulas on the formula sheet, okay? So let me show you that. You're going to learn these two formulas in section 3.4. So you'll learn present value of an annuity, which is another annuity formula, and amortization. And since I'm on the formula sheet, let's go ahead and notate it when we learn to use the continuous compound interest formula, okay? So this formula, remember when you want to use it, you're going to see the phrase compounded continuously. Okay, so that one should be really easy to spot. Okay, so let's move on to section 3.4.